Hi everyone, so we're going to start taking a deeper dive into the different planets that we see in our solar system. So we're going to start off by talking about our terrestrial planets. Remember, these terrestrial planets are planets that are made of rock. So those are going to be the first 4 planets in our solar system. We're only going to talk about 3 because we're going to be comparing those planets to Earth. So let's get started. So just a couple of questions that I want you to think about in the back of your head, even if you want to write some of what you think about these on the side. So which 2 planets, Mercury closer to the Sun or Earth, has the coolest temperature? Which planet is most similar to Earth? What is the composition of the surrounding clouds of Venus? Does Mars have liquid water on its surface today? Is life known to exist on Mars today? And some of the things that we are going to be discovering here is a sun-scorched planet, heavily cratered surface with an iron core. Venus is perpetually thick, poisonous clouds covering the entire planet. And Mars is an inspiration for scientific and popular speculation about that extraterrestrial life. So we're going to start with Mercury here. So some of the important details that I want you to pull out of this chart right here is our distance from the Sun right here. So Mercury is 0.38 AU, or 5.7 times 10 to the 7th. So it's that would be 5, 7, 9. And then we would add 5 zeros to the end of that. 1, 2, 3, 4, 5. So that's how far kilometers Mercury is from our Sun. Our orbital Earth rotational period over here. So our rotation here, how many Earth days for our orbital rotation. Another thing I want you to point out here is our temperature and atmosphere. Okay? So if we're looking at only 58.7 Earth days, so that's only about a quarter of the Earth year, so 88 days to rotate completely around the Sun. And then our temperatures here are 662 degrees Fahrenheit, so that's real hot. And then we have a very thin transfectant atmosphere here made of hydrogen, helium, potassium, sodium, and oxygen on Mercury. So some of the fun facts about Mercury here is that Mercury is only slightly larger than the Earth's moon. And so that's a really interesting fact of how small this planet really is. So the craters on Mercury and the Moon have very similar aspects to them. So they have these rings that surround them. So rings of mountains that surround these craters. And these impacts are very similar to our moon. So if we look up here at Mercury and our moon here, you can see how similar the surfaces look in comparison. So Mercury also has numerous long cliffs, and these are going to be called scarps. And they're believed to have formed when this planet cooled. So if we look at these different craters here, so the floors of the craters were flooded by lava on Mercury's interior. So after some time, the lava cooled, and it contracted to form this scarp. Remember, those scarps are long cliffs. And the crater was distorted from that scarp formation. If we're going to talk about Mercury's core, it takes up about 75% of the planet's diameter here, compared to the Earth's 55%. So there's really a lot more core inside of Mercury. and our mantle is very thin here, if we're looking at a comparison. So we have a really big core here and a really thin mantle on Mercury. Sorry. So one of the possible theories of why our iron content is so high on Mercury is that a collision with an asteroid stripped Mercury of that rocky mantle, which is why it's going to make it so thin here if you look in comparison to these planetesimals. So we have a really small area here compared to the core to its mantle. Mercury's rotation is also a little bit different, so it's not perfectly round each year. So it takes about 2 rotations for us to get a full, 3 sidereal rotations to get those 2 orbits around the sun. So if we look at this picture here, you can see how there's a difference in these distances as we're going around to get these 2 orbits around the sun. So it's a U combination that makes a solar day on Mercury that lasts 2 years. 2 Mercury years. So some other fun facts about Mercury is that it only has a 1% magnetic field as strong as Earth's. So it's a very light magnetic field here. It also has no permanent atmosphere. So our surface temperature here ranges, which is going to kind of affect, has a really large range if you look here. So that's really going to affect that atmosphere and what it's going to happen in here. So a mission to Mercury, a messenger spacecraft, was launched in 2004. And it reached Mercury's orbit in 2011. On its way, Messenger looped around Venus twice and then around Mercury 3 times before it entered Mercury's orbit. So a question that you can answer for extra credit is, why did the Messenger do loops around Venus and Mercury before entering an orbit? So if you find the answer to that and send me a quick little couple sentences of why that happened, we'll get some extra credit points here. So we're going to talk about Venus. So again, looking at some of the important details here, our average distance. It is a lot further away if you see here. So if we want to write this out again, so it's 1, 0, 8, 2, and then we're going to add another 5 zeros to the end of that. This is how many kilometers Venus is from our sun. And then another important thing that we're going to see here is right here. This is our orbit in Earth year. So it takes about 224 days for Venus to orbit the sun. Some more important information that we're going to extract here is our surface temperature and our atmosphere composition. So Mercury has a really unique atmosphere that we are going to talk about. So the clouds of Venus, so it's covered in a very dense layer of cloud that actually hides the surface of Venus. So unlike benign water vapor clouds on Earth, these clouds contain large amounts of sulfur dust and sulfur components, giving it that yellowy orange color. And this sulfur, it makes it a very uninhabitable universe, as well as the really high CO2 concentration that we're going to see here. So these clouds are made of concentrated sulfuric acid, which is actually a pretty dangerous acid. So because of this, we see dramatic increases in both pressure and temperature as we approach the surface of Venus. And at that surface temperature, it is 860 degrees Fahrenheit. So even though it's further away from the sun, we actually get higher temperatures on Venus than we see on Mercury. So this extreme heating of that surface is caused by the greenhouse effect. So because of that really high carbon dioxide atmosphere, the greenhouse effect is really amplified on Venus that allows it to reach that temperature of 860 degrees Fahrenheit. So the sun is trapping heat within the atmosphere with those clouds, which is really crazy to think about of how amplified this greenhouse effect really is on Mercury just because of that carbon dioxide percentage in its atmosphere. So we do actually have a few images of Venus's surface. So a Soviet spacecraft shows these rocky plains of fractured lava, and we can see these different pictures here that were taken. So we kind of have a color-corrected images at the bottom showing this rocky pieces and maybe even some lava right here, fractured lava pieces. Unfortunately, because of the really high pressure and temperatures on Venus, the spacecraft didn't survive to get more images of that surface. But a Magellan spacecraft is in orbit around Venus and is able to see through those thick clouds of sulfuric acid and gives us kind of a view of the sister planet. So we can see some volcanoes on its surface, and you see how the lava cracks are over here on its surface over here. So a couple different volcanoes that you can see and the lava flowing on the surface of the planet. So if we kind of look at this map, it kind of shows a topical map of Venus. So we can see the different heights, different mountains. So the higher up you get, it comes to a warmer color, so a yellow or a red. So we have some higher surfaces here on Venus. So it shows some large scale features on the planet. So if we look from a global view using radar images from this Magellan spacecraft, we can kind of see the different craters that were created on Venus. And our craters tend to be found in clusters. If we look over here, we can see that where we can see craters, it's usually a few in the same area. So this suggests that they were formed by a really big piece of debris that was broken up by the atmosphere and hit all in a similar area here. This is where we're going to stop. We're going to start with Mars next time. So remember to take our notes. We all should have written notes soon. So make sure we take our written notes here, and I will see you soon.